Alrighty. Hey, how's it going, hackers? We've got another workshop for you guys. This one is being put on by Prithviraj. It is an introduction to blockchain. I don't know about you guys, but I've always kind of been curious about blockchain. I hear it thrown around a lot, so I'm looking forward to learning a bit more about the technology behind it and what it is. Yeah, we're looking forward to this awesome workshop. Take it away, Prithviraj.
Okay, so hey folks, myself Prithviraj. I've been working with blockchain since 2 years, and I'm a second year undergrad, and I've been taking actively part in hackathon as a participant, as well as I've been mentoring in bunch of hackathons. So now today we are gonna look at introduction to blockchain. So there are no prerequisites for it. Only the thing is you should be eager to learn about new technologies. That's it. So it's a completely beginner friendly session, so let's dive deep into it. So in this session we'll be looking at what is blockchain and a brief history of blockchain, a purpose of blockchain, decentralized peers, encryptions, consensus algorithms, and of course smart contracts, which are very important in a blockchain. So first of all, what is a blockchain? So blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. A blockchain is essentially a digital ledger or transaction that is duplicated and distributed across the entire network of a computer systems on the blockchain. So for example, a blockchain is a chain of block which contains information. The data which is stored inside the block depends on the type of blockchain. So there are many type of blockchains. Of course, every blockchain is unique, and it contains a different kind of information in its blocks. For example, a Bitcoin blockchain contains information about senders, receiver, a number of Bitcoins that to be transferred. So the first block in a chain is known as Genesis blocks. Each new blocks that chain is linked with the previous blockchains. So of course, when a first block is created, it is known as the Genesis blocks, and it has its unique hash code, which is like linked to its next block, which connects it with each other. So that's kind of interesting. So blockchain is a distributed database, but it's also stored value. So 1 second, just put it down. Okay, so connected with a shared server. In a blockchain, list of record is stored as a block, and they are linked by using cryptography. So cryptography is an encryption method which blockchain used to create hashes for its particular block. So hence we can say the blockchain is a digital record and is used for recording transaction made with cryptocurrencies such as blockchain. So if we add a new block in a link with the previous block, it helps to cryptographically block from the previous block. By doing so, the block is permanently recorded to the blockchain, because as it is very difficult if something has been put in top of the blockchain to manipulate, because it has its unique hash code, and that hash code is linked with its next block. So if anyone tries to manipulate a particular block, its whole the chain gets manipulated, and the nodes can easily identify and solve that problem. So it's fascinating technology. You should definitely look into it. So let's look forward. In the blockchain, previous transaction alternate is very different because all the subsequent blocks need to be altered. The blockchain is pursued peer-to-peer database that is immutable. Okay, so let's look forward. So let's look forward to a brief history of blockchain. So a brief history of blockchain. So on 31st 2008, Satoshi Nakamoto, which is a Japanese person or a group which is unidentified, releases the Bitcoin white paper outlining a purely peer-to-peer electronic cash or digital assets transfer system. This is the first popular implementation of blockchain and is attributed as the birthing today's blockchain industry. Since then, additional blockchains have been popularized, such as Ethereum and various Hyperledger projects. solution, as well as numerous other including blockchain-like solutions such as guard times KSI products. So here the Hyperledger is a private blockchain, which is enterprise-based blockchain. We'll be looking forward in the next segment. And a blockchain technology was first outlined in 1991 by Stuart Haber and Scott Storrent, two researchers who wanted to implement a system where document timestamps could not be tampered with. But it wasn't until almost 2 decades later, when the launch of Bitcoin by Satoshi Nakamoto on January 2009, that blockchain had its first real world application. So it was planned in 1991, but it got implemented by Satoshi Nakamoto in 2008. So it took that much time to get implemented because there was no real world application for it. So let us look at what is the definition of blockchain. So it is an open source distributed ledger that records transaction between two persons efficiently and in verifiable and permanent way. So each transaction is secured with digital signature that provides its authenticity. Every block contains a cryptographic hash of previous block and a timestamp and the transaction information. Because as a block is contained, it generates its unique hash code, which is unidentified, and it contains that hash code in the next block, as I said it before. So which contains its uniqueness. So what is the purpose of blockchain? One second. Okay, so what is the purpose of blockchain? So blockchain uses an online ledger which is very secure. There is no third-party interface. It uses distributed ledger which is very transparent. It is a digital world offering many new tools, and there are many centralized administrations. Since there is no third-party guarantee, the cost is very low. But nowadays on the Ethereum blockchain is very popular nowadays. But the problem comes with it is that it has very high gas fees. So something known as Ethereum 2.0 is gonna come up and remove all the problems from it. Okay. Okay. So blockchain in cryptocurrency. The term blockchain is often used to refer the cryptocurrency. Many people misunderstood like blockchain is also known as cryptocurrency, but that is not true. The blockchain is a technology which is used as which has a subpart known as cryptocurrency. On top of blockchain, the cryptocurrency is made, and the cryptocurrency is a medium of exchange such as US dollar. It is just an application in the form of e-currency such as blockchain. It is governed by any financial institutions because it is an decentralized cryptocurrency, so anyone can use it from any part of world. There is no any centralized authority controlling over it. The main difference between blockchain and cryptocurrency is the cryptocurrency is created and held electronically in the forms such as virtual wallet. So it is decentralized and it is non-governed, as I said before, by anyone, whereas blockchain is advanced record and it has all information related to cryptocurrency exchange and overshared systems. So keep in mind, the blockchain and cryptocurrency are two different types. Don't mix it up because they are totally different things. So here are some blockchain examples, like where we can use blockchain. So we can use blockchain in food industry. We can use it in real estate. So in real estate also uses blockchain technology by allowing anyone anywhere in the country to invest in real estates, which gets kind of easy because we have to like go there, look at the land. It gets quite easy from anywhere to buy the real estate. In food industry, network from farmers to groceries is very complex, and blockchain makes it easier by tracking down foodborne illness challenges. So again, the retail products can be purchased, and if there is any malfunction, blockchain helps to access information regarding the products. Sorry. So there are many blockchain which are working on this real world applications for real estates and social media. Also, there are many blockchains which are working on this project, and it will be soon come up. So let us look like more technologies used in the blockchain. So blockchain uses bunch of technology. So here are some of them. Blockchain is a system comprised of transaction, immutable ledger, decentralized peer, encryption processes, consensus mechanism, also known as consensus algorithms, and optional smart contracts. So let's look out one by one. So let's explore these concepts. So transaction. A blockchain is essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer system on the blockchain. So each block in the chain contains a number of transactions, and every time a new transaction occurs on the blockchain, a record of transaction is added to every participant's ledger. The decentralized database managed by multiple participants is known as DLS, also known as distributed ledger technology. So I'll be sharing a bunch of links in our Discord channel. So I'll be sharing our Bitcoin's white paper, which was published by Satoshi Nakamoto, and also I'll be sharing where you can look like how a blockchain's block look inside of it, and how the transaction has been done inside the blockchain. You can look out the hashes and all. So I'll be sharing the bunch of links in our Discord channel, so look out for that. So let's move forward. So yeah, so one of the key technology used is immutable. So blockchain is immutable. So what immutability does mean? So immutability means unchangeability. In computer science, as immutability object is an object whose state cannot be altered after its creation. So immutability is one of the key features of blockchain and Bitcoin technology. So immutability transactions make it impossible for any entity, for example, a government or a big corporation, to manipulate or replace or falsify data stored on a network. So it is quite interesting, and it is the main key feature of blockchain. As we are existing database, blockchain retains data via transaction. So transaction is immutable and orientable. Like a ledger written in an ink, an error would be resolved with any entry, but immutability is something that can't be changed. Okay, so the difference is that once written in the chain, the block can be changed, but it is extremely difficult to do so, requiring the rework of all subsequent block and consensus of each, because there are a bunch of nodes all over the world who are like constantly trying to validate our transaction by solving complex mathematical equations. And if they see someone's trying to manipulate a data from a block and its hash has been changed, so they immediately try to solve that problem and remove that person from out of that blockchain, and it gets solved easily. So it is quite impossible to change something in blockchain. But there is something known as 51% attack. So you should be knowing that. So if a person has control over blockchain of 51%, so he can control the whole blockchain. So he just need to be uh, gaining a control of 51% of the nodes in an blockchain, so he gets the whole system under it. So yeah, let's move forward. So there is a key feature of blockchain, also known as decentralized peer. So rather than centralized hub and spoke type of network, blockchain is decentralized peer-to-peer network where each node has copy of a ledger. Because as in our centralized system, a person is sitting there from a central authority and has all our data in it. But in a decentralized way, there are nodes who has a copy of our ledger, so that's quite safe for us. So a peer-to-peer is also known as P2P services in a decentralized platform whereby two individuals interact directly with each other without intermediating by any third party. So instead, the buyer and seller transact directly to with each other via P2P service. The P2P platform may provide services such as searching, rating, payment processing, etc. There are a bunch of services provided by P2P, and decentralized peer is a key feature of blockchain. Okay, so yeah, so here's a encryption method in a blockchain. So firstly, let's look what is an SHA-256 hash. A block also has a hash. It can be understood as a fingerprint which is unique to each block. It identifies a block and all of its content, and it's always unique, just like a fingerprint. So once a block is created and any change inside the block will cause the hash also change. As I said earlier, if anyone tries to manipulate a block, its hash get changes and its previous block's hash has different. So node can easily identify that someone has tried to manipulate, and node tries to fix it immediately. So therefore the hash is very useful when you want to detect change in an intersection. If the fingerprint of a block changes, it does not remain the same block. So basically each block contains data and its unique hash and its block of hash, previous block's hash. So a typical Bitcoin blockchain inside a block contains these three things. It has its unique hash, it has the previous block's hash, and in the data. So every blockchain has some different things, but Bitcoin blockchain contains these three things. So let's look out for like consensus algorithms, also known as consensus networks. So a consensus algorithm is a process through which all the nodes of the blockchain network achieve a common agreement about the actual state of distributed ledger, as well as design consensus protocol can ensure the fault of tolerance, authenticity, and security of blockchain system. So consensus algorithm, so when a transaction has been done, the network of nodes, the process that the node decides if this transaction is valid or not, that is known as consensus algorithm. You may have heard about proof of work, proof of stake, proof of state, and there are a bunch of other consensus algorithm. So Bitcoin uses something known as proof of work, and Cardano uses something known as proof of stake, and Ethereum currently uses proof of work, but it has many disadvantages over here. So something Ethereum 2.0 is gonna come up and scale the whole solutions for it, and it's gonna be in proof of stake. So it's gonna make sure that every problem has been solved, and it's has the low gas fees over there. So ensure that the next block in the blockchain is one and only version of truth, as I said, keeps powerful adversaries from derailing the system and successfully forking the chain. So many consensus mechanisms, each with its pros and cons. And here are a bunch of consensus algorithms here: proof of work, proof of stake, proof of activity, proof of burn, proof of capacity. But the oldest one is proof of work, which Bitcoin uses currently. Okay, so you might have heard about smart contracts, so which Ethereum uses currently. So smart contracts are self-executing contracts containing the terms and conditions of an agreement among peers. The terms and conditions of the agreement are written into code. The smart contract executes on the Ethereum blockchain decentralized platform. The agreement facilitates the exchange of money, shares, property, or any assets. There are two widely used programming language for writing Ethereum smart contract. There is one Solidity and one known as Serpent. So here, smart contract is nothing but the computer code provides business logic clear prior to block submissions. So Bitcoin doesn't have any smart contract, but Ethereum has a smart contract which requires solidity language, which is written in solidity language, and Hyperledger blockchain, which is currently a private blockchain which provides enterprise solutions to them, because of course some businesses don't want their data to be in public, so they use this Hyperledger to keep it safe and private. So Hyperledger uses various languages such as Go, C++, and etc. So there are many blockchains which uses smart contracts. Also they has their use cases, so it may differ from blockchain to blockchain. So okay, so okay, this is wrong slide. Okay, so here are some advantages of blockchain. As we have seen, there is great transparency. It is highly secure. It is easy to traceable if anyone tries to manipulate a blockchain. So it can be easily visible for a node, that if someone tries to blockchain, so it is easily traceable. It is high efficiency and speed. It has low cost, but low cost thing is it may differ from blockchain to blockchain, as I said, because there is a Tron blockchain which is really cost efficient. It has like really cheap. If a transaction has been processed, it has really cheap gas fees. But if that transaction we did on a Ethereum blockchain, so it may cost up to like $40 to $50 per transaction on for gas fees only. So it is quite high, but Ethereum 2.0 is coming and it will deal with all these solutions. So there is 0% of fraud, not like zero, but there is like minimum percentage of fraud. So but it is extremely volatile, yeah. So as we know, uh, if there are advantages, there must be a disadvantages as well. So here are two of them. So more power consumption, as I said, like the nodes are constantly trying to validate our transactions by using their hard GPUs and solving the complex mathematical equations. So it consumes really very much electricity, which causes global warming. So it is like more power consumption. And the next point is can be a regulatory problem for our financial institutes. So as there is no centralized peer included in it, so it can be problem to track down, like if any fraud happens, like we can't go and catch one person or bank, like where is my money. So that is something you should know about. And of course, like thank you, and there is many more things to learn about, and you should really look into it, the blockchain, because it's a really emerging technology and you should be looking at it. And here's my linker tree, and I'll be posting it in the Discord channel. You can connect me if you had any questions about this. You can connect me over there. You can ask anything. And of course, I'll be sharing Bitcoin's white paper link, and of course, like what contains in a block of Bitcoin blockchain. That all the links I'll be connecting. I'll be sharing in the Discord. So yeah, that's it. So thank you for joining, Austin. Over to you. Okay, one second. So I'll show you some Bitcoin. One second. So yeah, as you can see, right. Uh, okay, Austin, it's over. It's done.
Hey, sorry, we were having some technical difficulties. Like my Zoom's kind of whacking out on my
Okay.
computer. Sorry
Okay.
about that.
Yeah, fine. So I'll be sharing some links in our Discord channel. Is it okay?
Yes, definitely. Please do. We'd really appreciate that. Additional resources are awesome.
Okay. Okay.
All right,
Thank
awesome.
you,
Well, thank you
folks.
so much for your presentation, man. I really appreciate it. Sorry, my computer was like bugging out at the end there, and
Okay.
I couldn't send you off with a proper thank you. But thank you so much for your time. We really do appreciate it, man.
Yeah. No problem.
Awesome. See ya.